Hi, this is Thijs from Varnish Software. In this video, I'll show you how to accelerate and how to scale JFrog Artifactory setups by putting a Varnish Virtual Registry in front of it. JFrog Artifactory is a well-known universal repository manager that offers registry interfaces for the different files that you need as part of your software supply chain. Artifacts, as we call them. They have support for a vast array of package types, and despite the incredible value that they bring to organizations, there are some typical scalability and performance issues that can be addressed by adding a virtual registry in front of it. Now, the Varnish Virtual Registry, as the name implies, is not a physical registry. It's a proxy layer that you put in front of your actual registry to accelerate it. Through intelligent caching, artifacts can be served directly from the virtual registry, which offloads a lot of pressure from your JFrog Artifactory. Let me quickly show you how easy it is to get started. The Varnish Virtual Registry, which we call Project Orca, is available on www.varnish-software.com/orca. And as you can see, it's as simple as doing a Docker pull. But if you move down, you have the different install types. You can deploy it locally via Docker, you can orchestrate it on a Kubernetes cluster, or we have packages for Debian and RPM-based systems. By navigating to the documentation pages, you'll learn how to install, configure, and use the Varnish Virtual Registry, or Orca as we call it. Configuring Varnish Orca is pretty simple. You rely on a single YAML file with your virtual registry entries. Here's an example where we already have entries for the Docker Hub, for public Docker images, and for npm packages using npm.js. Then it's just a matter of adding your Artifactory entry, and the IP address that it points to is a self-hosted JFrog Artifactory on AWS. The goal is for us to deploy that to AWS as well. And while this config file applies to the different incarnations of Orca, we'll specifically use a Helm chart to deploy it onto a Kubernetes cluster that is also hosted on AWS. If you want to deploy Varnish Orca on a Kubernetes cluster using the Helm chart, you need a values.yaml file to override the default settings that are related to the service that Orca exposes itself on, or the location of the TLS certificates and the license. But of course, the virtual registry entries will look familiar with our Docker Hub entry, our npm.js entry, and our Artifactory entry that points to the IP address of that self-hosted JFrog Artifactory setup on Amazon. We've also added a routes entry, meaning that you can have an extra route to match the Artifactory registry entry, but we're doing that based on a glob pattern. So all the host names that start with localhost followed by a colon and then another value will match this. This ensures that a Kubernetes cluster can actually use a local host registry on the predefined port, in our case that's 30080, and pull images from there, from Orca directly, knowing that the source of truth will ultimately be JFrog Artifactory. And that rapidly increases the speed of deployment within Kubernetes clusters. But let's continue with the deployment of Varnish Orca in our Kubernetes cluster. And we can run the install with a little shell script we have that runs the Helm install, chooses the public Orca chart, and injects the values.yaml. And as we run the deploy script, you could see that the Helm install was successfully completed. Then you can run kubectl get po to get an overview of the pods, and you'll notice the Varnish Orca pod there running and ready to accept traffic. To ensure that external traffic from outside of the cluster reaches the pod, you'll need some kind of ingress or gateway, and we've opted for the Varnish gateway, which is our own implementation, ensuring that outside traffic reaches Orca. Accessing specific artifact types happens based on the registry key. We defined Artifactory as the key, and that allows us to pull in different types of artifacts. We could do Docker pulls, Helm installs, npm installs, you name it. Let's pull in a Docker image from Artifactory through Varnish Orca. The image is called to do, and this is what it looks like in Artifactory, and that's the one we're going to deploy. And for that, we use the Artifactory Virtual Registry key name as part of the domain. We can do a Docker login on artifactory.demo.artifactcache.com and leverage the access control system in Artifactory without having to re-implement it ourselves. And then we can use that same endpoint to pull in a Docker image. To prove the impact and effectiveness of a Varnish Virtual Registry deployment, we'll run a set of automated tests using K6, a well-known open source load testing framework. The JavaScript-based scenarios that will run, which you see here, will really hit Artifactory where it hurts, because we know JFrog Artifactory is notoriously database bound. So if you run a lot of parallel requests on different artifact types that need different records in the database, things will slow down and the database will become a bottleneck. In this script, we're targeting the self-hosted Artifactory setup that we have hosted on Amazon, and the tests run in 3 stages. A smaller flavor, medium and large, each running 20 seconds, and for each of the scenarios running within the stages, their own concurrency levels. There's 4 scenarios that we're running: AQL searches, Artifactory query language searches that really hurt the database, we know this. At the same time, we're uploading a massive amount of small artifacts with random content. We run metadata queries, and at the same time download the artifacts, and that's what we'll really monitor. A quick but important disclaimer: the K6 script that you saw might not be an exact representation of what you would do in production. Specifically the AQL search queries and the metadata API calls, which add a little bit of extra pressure to the database that we would otherwise need a much bigger setup for to do that organically through artifact downloads. So let's get started. Let's log into a Linux server also hosted on Amazon that has K6 on it and where we can actually run that script. And besides the K6 script, there's also a .env file with environment variables such as the Artifactory URL, the username and the password that we want K6 to use. This happens in the k6.sh script where the K6 run command gets executed for our artifactory.js file. We read the .env file, process the lines as individual environment variables, and reduce the output. And then we run k6.sh. The script contains the 4 scenarios, as you can see here. And the traffic ramps up all the way to 320 virtual users. The scenarios run in parallel, and they run all the way up until a minute. Let's fast forward the test until we reach the interesting part. As the testing period of a minute has elapsed, we see a bunch of request failures coming in, specifically with the message request timeout. And these are requests that couldn't be satisfied within the given timeline, and as the traffic ramps down and gracefully shuts down, those errors appear. The threshold for the maximum request duration was exceeded. And looking at the definition in the script, we said that the 95th percentile of the request duration would stay below 5 seconds, and that's not the case. It is a full minute. However, more interesting data appears when we look at the measurements for the different scenarios that we run. The AQL scenario performs particularly poor, but that was by design. We did that artificially to add more pressure on the database. And with a 95th percentile of a minute, even for the smallest flavor, we know that scales pretty poorly. And that also applies to the metadata API calls, which all reach a minute at the 95th percentile and even 4 seconds at the larger in terms of the medium request duration. Surprisingly, the uploads perform a lot better. At the small and the medium stage, it's all acceptable. At the larger stage, a 95th percentile of more than 15 seconds is not good. But we don't really care about that. What we really care is about the downloads, because that's what we want to measure, and that's what you're going to do. You're going to download artifacts. Let's look into detail. At the smaller stage, we have a median request duration of 117 milliseconds, yet we still hit a minute at the 95th percentile, meaning there's probably a lack of connections to hook into. At the medium flavor, yes, still a minute at the 95th percentile, and the median request duration already rises to 450 milliseconds. And at the larger stage, at the medium, we are already surpassing a second, and at the 95th percentile, we are just not hitting a minute. So let's run the test again by opening up another SSH session on the same server and by using Orca. So we change the environment file, modify the Artifactory URL environment variable, and instead of using the self-hosted Artifactory demo setup, let's point it at artifactory.demo.artifactcache.com. This is the endpoint that we host on our Kubernetes cluster. So by running the K6 script again, the test will start over again. And as you can see, the scenarios are going to be run again in parallel and the traffic ramps up. So let's fast forward again and see the outcome. As traffic winds down, we see request timeouts again, but they don't come from the downloads. Those have completed. It's the AQLs and the meta calls. Uploads and downloads have successfully completed. So let's accelerate the tests again to complete the wind down as quickly as possible and look at the results. The results are very promising. However, the AQL calls and the meta calls are still slow, but they're less slow than in previous times. But then again, that doesn't matter because that's not what you're interfacing with. The downloads, that's particularly interesting. And at first glance, the results are very promising. So let's do a quick side-by-side to compare the tests without Orca and the tests with Orca and see how much the gain is. When we scroll down to the large flavor of the download scenario, and we compare the 95th percentile of the request duration, we see that we start out without using a virtual registry with 58.82 seconds at the 95th percentile. When you use Orca, you drive this down to 3.36 seconds, which is a 17.5x performance improvement. And when we compare the median values, we're going from 1.23 seconds down to 278 milliseconds, which is a 4x performance improvement. Now keep in mind that this is a pretty small setup, and there's also more than 20,000 artifacts being generated throughout the tests that are randomly consumed in the download scenario. So not everything is a cache hit. And on bigger production grade environments with a more controlled set of artifacts, your hit rate would be much higher and the offload and the performance benefits would be even greater. So as you can see, that's where the Varnish Virtual Registry really shines. And that's all I have for today. Thank you for watching this video. I hope you see the value of putting a Varnish Virtual Registry in front of your JFrog Artifactory. And in fact, I encourage you to get started straight away. Just go to www.varnish-software.com/orca and you'll find instructions on how to deploy it via Docker, via Helm, or via Debian or RPM packages. You'll also have a form to request a free trial license for the premium features. There's tons of documentation out there, and you'll also find a widget to reach out directly to us.